Hi guys, this is Muhammad Shafi. I'm from India. As you can see my profile, I'm a Microsoft Certified Systems Engineer on Windows NT, and I practically upgraded myself on remaining versions of Windows Server until Windows Server 2016. And apart from that, I am a CCNA on routing and switching, CCNA security 3 times, and recently I acquired my CCNP and core certification. I'm also an IT instructor and have been a network administrator in a renowned organization here in Saudi Arabia. The purpose of making this video today is just to actually the target audience for this video are those guys who are already familiar with the basics of IP addressing, specifically IPv4 addressing. But as a quick recap or as a quick review, I would like to go through these slides for a while before I try to teach you how you can try to calculate the IP addresses over the valid 254 IP address range in class C. Okay, class C and class A, B, C, these are all the classes of IP addresses that we'll be discussing in this one. But before we start and understand this one, let's see what is IPv4 addressing and basically what is an IP address. An IP address is a 32-bit logical address, especially the IP version 4 I'm talking about is a 32-bit logical address. By logical I mean to say that it can be changed whenever you want. And in contrast to this, you have a media access control address, as we know by MAC, which is actually a hard-coded address in every device, and it is unique throughout the world. Okay, that's the reason why MAC addresses are considered to be the physical addresses, burned-in addresses inside the devices, whereas the IP addresses are considered logical because they can be changed anytime. So you have to remember this. MAC address, let me just invoke my pen. Okay, the MAC address we are talking about is media access control address, is a 48-bit address actually expressed in, I can say, hexadecimal. And I sincerely hope you guys, since the target audience for this video are those people who are already familiar with IP addressing, so I already blindly assume that you have the idea of numbering also, numbering systems like binary, decimal, hexadecimal. Okay, I would like to clear or take separate video on numbering system later on, but understand this one. A bit is either 1 or 0. A digit in the form of 1 or 0 is a bit. Since it has only two faces, it takes the base value of 2. Okay, because the binary has either 0 or 1. Okay, 0 representing the off state, 1 representing the on state. So hexadecimal values have base 16, and we will discuss them later on. So just understand, IP address is logical, this is physical. Okay, so moving on to the second slide. Here I just try to revise few things for the sake of your understanding, just to make you understand the format of IPv4 addresses. If somebody is new to IP addressing, he is a networking guy or learning networking, maybe he'll find beneficial. The format of IPv4 addresses can be like this, and each IP address can be broadly divided into two categories. One is the network ID. Over here is my pen, comment. Okay, need to invoke again. Yeah, this one is the network ID. This is the one, and this one is the host ID. Two portions. See here, it has been divided into two. Okay, broadly you can divide into two. And further, these two sections representing net ID and host ID can be divided into four equal sections called octets. Oct means 8. We know this. Oct means 8. Because each one is an octet, each will be comprised of 8 bits. 8 here, 8 here, 8 here, and 8 here. So equally they are divided into 8 bits, totally making 32 bits. Okay, now based on the classes of networks, class A, B, and C, these IP addresses will take different formats. Like in class A network, only first octet has been reserved to represent the network ID on that particular network of any network, and the remaining 3 octets are left for manipulating host. Okay, how many number of hosts you can have, we'll come to that one and later on in the slide. Likewise, class B has 2 network portions and 2 host portions. Okay, out of this 32 bit or 4 sections, you have 2 divided for network representing the network ID, 2 for the host ID. Class C has 3 and just 1 as host. So this means that in case of class A, we are going to have more number of computers in one single network compared to class C, which is exactly opposite of this. Here you have more number of networks, there you have more number of hosts, here you have more number of networks. Okay, so as a side note, I have already specified here, this means 8 bits and bit is either 1 or 0. Okay, now to the next slide. The default subnet mask. Okay, subnet mask is actually another address which is used to distinguish between the net IDs and the host IDs in any given IPv4 address. Okay, subnet mask of 255 in any octet represents that this particular octet is a net ID, and any number corresponding to 0 in any given IP address is actually a host ID. Okay, this will be more clear actually, since as you saw in the previous slide that in class A networks we have just one octet reserved for representing net ID. So in the decimal language or the decimal format, when you try to type in the IP address and the subnet mask to make your PC or a device aware that how many octets have been reserved for net ID and how many have been reserved for host ID in this IP address, you have to express it in the number format, and the most easiest one is the decimal one here, because remembering this values of binary will not be easy for anybody. Here it's easy because these are all 8 ones. The binary equivalent of this 255 will be nothing but 8 ones. Okay, it will be nothing but all 8 ones here, 8 ones, 8 zeros, 4 zeros, like this. This is equal to this. But if you come to other numbers, you will find it difficult to remember because there will be a combination of ones and zeros. So that's the reason why, to make life easy, the Internet Engineering Task Force and other guys, they have actually adopted this method of representing or typing the IP addresses. Okay, on PCs and other devices. So you will type the IP address in decimal format, which is more easy to remember. Okay, so whenever you want to tell the PC that this first octet, or starting from the first octet, okay, is a net ID, you will tell by typing 255. Okay, so supposing I have an IP address, any IP address, take example of this, they are represented like this. If this is an IP address, irrespective of any class, I want to tell my PC that in this IP address I have reserved 2 sections or 2 octets for network. I will write down my IP address like this. IP address will be this, subnet mask will be this. This is IP, this is subnet mask. If I reduce 255 or increase to 55, it will change the net ID and the host ID values inside this given IP address. Okay, so 255, anything corresponding to 255 is taken as net ID, and anything corresponding to 0 is taken as host ID. I hope this one is clear. Okay, so let's move on. So these are the default subnet masks for different classes. You can see here class A has 255 in first octet, remaining 3 octets 0 to represent the host IDs. B has 255 in 2 octets and 2 zeros, and C has first 3 octets 255, fourth one 0. Okay, now the default subnet mask as we discussed, and the IP addresses, if they are written like this, it's easy for you to derive the net ID and the host ID in any given IP address. If this is a class A addresses, they have I'll give you the range later on here, or I will try to mention then. Class A usually has a range from 0 to 127, where 0 and 127 are reserved, you cannot use them. Okay, B has a range of IP addresses starting from 128 to 191. C has 192 to 223. This is only for the first octet. Okay, you have to remember that this is only for the first octet. If you find the number between these, so you can easily figure out this is a class A address, and you know what is a class A address format. The default subnet mask will be 255.0.0.0, representing 255 to be corresponding to the net ID, 0 corresponding to the host ID. Likewise, if you have a range of first octet in this one between 128, starting from 128 to 191, then it is considered as a class B address, wherein you are supposed to type 255.255.0.0 as your subnet mask on the devices. Class C has opposite of class A. There you have just one, here they have 3 net IDs and just one host ID. So this is how you try to figure out the net IDs and host IDs. Now you can see in any given IP address, like such as class A, if somebody asks you to write down the network address, the net ID and the host ID, you can easily write down like this. Remember, a network address is an address wherein the net ID is as it is. You can see it is as it is, but all of the host IDs will be zeros. Okay, that is the you can say a definition of a network address. Net ID as it is, host ID is all zeros, represents the network. So this is the network 121.0.0.0. By looking at the first octet, you know, because it is lying between 0 and 127, this is belonging to class A. So when it is class A, for sure only one section or first octet is reserved for net ID, the remaining are for host ID. So net ID will be only 121. You are not required to fill this one. In some books and some people, they usually go with 0.0.0 here. Net ID and network address are changed interchangeably, but the more accurate will be is to just mention 121 as the net ID, because we are not talking about the network address. Network address is this, net ID. In this network address, complete address, what is the net ID? This is the one. Host ID, you need not write anything here. I found some people writing 0. 0 will make things entirely different. Somebody sends a 0.132.201.16, meaning that that network belongs to a reserved class of class A. So never write 0 here. X, just write down any letter which is not compatible to be written in, inside the boxes or fields available for IP addressing inside the PCs. So host ID is 132.20.201.16 in this network. Likewise, we have for class B, if you have class B address, in the given IP address 173.221.142.187, network address will be again like this, net ID as it is, host ID is zeros. Net ID will be only 173.221, host ID will be 142.187. Okay, moving on to class C. class C has 3 octets, so you can note down here that I have taken only one octet at 0, and net ID is represented by just 200.125.18. host ID is just 31. Okay, this means this is the host number 31 on this network, and this, wherever you will find the net IDs, they are going to remain common on every computer. Okay, no two, if you make a minor change, that guy will be on another one. For example, if I were to connect two computers in the same network of class C, supposing this is computer 1, okay, and this is computer 2. If I want to connect them by some means and try to bring them on the same network, I have to make sure that I am trying to type the net ID first of all same on both of them. Okay, where I will be supposed to make uniqueness is the 4th octet, which is the host ID. If this one is 31, I cannot have 31 for the second guy. I have to have number other than this. And how many numbers can I have? What is the beginning range and range? I will show you in my Excel worksheet. But just remember, in the 4th octet, two computers cannot have the same IP address. They can have the same net ID, but host ID should be different on each computer participating in a network. Okay, if I make a minor change here and I, instead of 18, I type 19, in that case this machine will not be able to reach this one without the help of a router. And router is a device which connects multiple different networks. Okay, so this is how you have to remember this. So that was all about your IP address. Now this is a summary for this. You can see the format. Class A will have 1 octet as net, remaining 3 hosts. B will have 2 octets reserved for net ID, 2 for host, and their default subnet mask. And class C, 3 octets and this. Also, you will often find the subnet mask being represented excuse me, as /8, /16, /24. What does this mean? This means that it is actually referring to the binary, that is binary bits inside a subnet mask. How many bits are turned 1? Because 255 means all ones, 8 ones. So since we have just 255 in class A networks, this means is I have only 8 bits representing my network ID. Since we have 2 octets representing net ID here, 8 plus 8 will give me 16. So okay, whenever you see, do not get confused with /24, 16 and so on. This clearly or shows you or indicates that what are your number of ones inside a subnet mask, how many ones you have, and all those ones will be written in one sequence without any break in subnet mask, because subnet mask is the actual address which will tell the PC or any other device to understand how many sections in the given IP address are reserved for net ID and how many are for the host ID. It is the only address which tells the PC to make it this distinction. Otherwise, it will be difficult to distinguish without the subnet mask whether it is just 1 octet, 2 octets or 3 octets. Okay, that's how. Okay, each octet of net or host ID is 8 bits, therefore total number of binary bits in any IPv4 address is 32 bits. Because just 1 octet is reserved for net ID, network ID in class A network, default subnet mask will be like this. Likewise for class B and class C. Okay. As far as the range is concerned, I did not include 0 here because this is the valid range for class A networks. They are for extremely large networks. Unfortunately, you have just 126 class A network, you can say, each one supporting more than 16 million computers in a single network. You can imagine the addresses begin with 1 to 126. So 1 dot, like for example, if I were to write down the class A address, network address, I say 1.0.0.0/8, meaning that I have just 1 octet reserved for subnet mask. So this one have, sorry, /8 here. Okay, so likewise I can have 2 dot 0 dot 0 dot 0, 3 dot, and so on. Each network of class A will have more than over 16 million computers or devices, holding valid IP addresses for communication. As far as networks are concerned, you have just 7 bits to play with, because in the first octet they have reserved the first bit, because if you look at the first octet, it is comprised of all 8 ones, right? Like this. So the internet experts have reserved this bit and they made it at 0. This one is 0, which leaves or gives the indication to the routers that this is a class A network. So we are only left with only 7 bits to play. That's the reason why we have around 128 2 to the power of 7 total networks in this one. But out of this valid are how many? We have just valid network range starting from 1 to 126. You cannot have all zeros and all ones. Okay, so if I turn this to be all zeros, this will become 0. If I tell this one all ones, excluding this one 0, I will not be able to reach. Like, I'll keep this 0 as it is, and remaining, if I turn this to 7 more zeros, so this becomes 0 in decimal, right? Likewise, leaving it as it is, I write down the remaining 7 ones. So if I convert this binary to decimal, what should I get here? I will get, you see, I need to subtract 128, so I will get 127, because totally the size of one octet is 255. All 8 ones will be equal to 255. So values will begin like this: 1, 2, 4, and so on. You can see the binary to decimal conversions. Plenty of them are available on the YouTube. Okay, and some of the other videos I'll try to explain how to convert these numbers. But since this video is for those guys who are already well versed in IP addressing, I just want to calculate some addresses higher than 254, I'm making this video. And this is a brief introduction. I'm sorry if I'm getting long, but trying to make my video as short as possible. So this is how the range is calculated. Likewise, in class B you have 1 0 as a reserve bits and remaining are. So you might be wondering why, because if you see how this was calculated, this was calculated based on the number of bits left. See, 3 octets means you have 24 bits. So 2 to the power of 24, we are taking the base as 2 because we are dealing with binary. Binary has only 2 faces, ones and zeros. That's why 2 to the power of 24 minus 2. This minus 2 is for those 2 reserve addresses that cannot be used on any device for communication. They are reserved for a specific purpose. Okay, one of them being showing that this is the network, another for the broadcast in the network. Okay, broadcast is used for so many purposes by the devices, in order to locate the MAC address of other PCs. Okay, in order to route the information from one network to another one. For various purposes there will be a broadcast going on. We cannot hear the broadcast, but computers are very chatty in the network. They keep on trying to figure out things for themselves. So this is how. Here I got 2 to the power of 16 because 2 sections are left, only 2 octets are left for host ID manipulation. That's why we have 8 plus 8 16. So this is equal to 16,384. Sorry, 65,534. And these are the networks, number of bits based on this one. Okay, and likewise for class C. So you have highest number of computers in class A, least in class C. D and E are reserved for special purposes, so we'll not be discussing them. Okay, in this IPv4 we have some private and public address ranges. These are the private ones. Other than them you have all public addresses. Anything that lies in this range is considered as a private address range. You can see here 10, .0.0 is starting and going up to 255 in octet with /8. This is for class A guys, and class B guys, they have reserved up to here /12. You can see, meaning they have taken some extra bits starting from 16 to 31 in the second octet. Class C has starting from 0.0 to 255.0 on 255.255. All these are private addresses, meaning that actually they are blocked by internet service providers from reaching out the internet. It is not that they cannot be reached, they can be, but they are blocked. Okay, RFC 1918 addresses request for comment gives you the details regarding this one. Examples are here for the few private IP address ranges you can see here in my slide. Okay, so I hope this was very informative for you. So let's go back to actual calculation of IP addresses. I have prepared for your convenience. It's easy to write down these addresses and pull them down for the sake of your convenience. You can take any IP address. I have taken 192.168.0.1. I just want to show you how you can prepare in Excel. If I were to type the addresses, one method is to type like this, say 193.255. any address 3 octets, because class C has 3 octets reserved for net ID. I have to maintain the uniformity. .0 is the network address which I cannot use it, so I will start from 1. So when I do like this, I can just simply click on this cell, and then using the drag handle I can drop it until I reach the maximum in this network, which is 254. I can go up to 254 because 255 is the broadcast. This one is the broadcast, I cannot use it. See, so it's easy for class C. You can say, okay, what is address number 100? You have to check for row number 100 to check that address. What is it? Easy. Without even checking, you can tell me that which one is the 100th address, which one is the 50th address, or 80th or 83rd address, like this, very easily. Just you need to mention to me the net ID as it is and just change this first ID. Supposing I say, okay, on this network, what is address number 175? You will say it's 193.255.101.175. very easy. So calculating addresses up to 254 is easy, but it gets more difficult when somebody wants to go beyond this one, and this was the purpose of making this video. So I want to show you in short how you can calculate and verify these addresses. So since we know how to calculate up to 254 valid addresses, we'll try to calculate something more than this. Okay, as far as creating the list of valid IP addresses is concerned, it's easy in Excel to create, as I showed you just how you can drag and complete this one, but you can go up to few thousand addresses, my friends. You will not be able to complete the whole range so easily. It is really time consuming. Like you have to, supposing you were supposed to note down 65,534 valid addresses, you have to keep dragging. But for your convenience, I have made some couple of around 3,000 addresses, close to 3,000, just about 20 here. You can see here, this is I can take you control down arrow will take me to the last one. See, 2815. Control up arrow will take me to the first one. Okay, so let's try to see what if I want to calculate an address, which is, first we'll make sure that we can do through Excel as well as from this one. Okay, let me just see. Supposing I want to see what is my address number 4 ones, 1111. So one method, if you have already prepared an Excel sheet for any network, class B network, okay, if you had decided that I must prepare one, it's difficult to carry everywhere, okay, and you are dependent on a computer to open the file, or at least you have to copy in your mobile smartphone and then open that and try to search for it. It's really difficult to figure out, but I'm showing you this is one of the methods you can use. 4 ones. So I can say, okay, in column A I have actually prepared all those addresses, so I'll say A followed by my number I'm searching for. You can see here I got 172.16.4.87. see here 4.87. let's try to verify using the calculator how you can figure out this one. 4 ones should be divided by 256 because the total size of one octet is 0 to 255, which is equals to 256. You get this value. 4 is for your third octet. You got 4 here, see, 4. Now what I will do, I'll subtract this 4 from 4, minus 4, whatever number you have there, just subtract it. Okay, still you are not done. This value should be now multiplied by 256 to get 87. See, 4.87 corresponds to 1111th address. Likewise, if I want to randomly calculate, for example, I want address number say 2147, so I'll say divided by 256 minus the same number multiplied by 256. So what I got for first one, I did not check, I did not know. Let me just try to revise. I said, I think 2147 divided by 256. Make a note of this one, this is important. 8 you got here, okay? 8 is for your third octet. And now minus 8 into 256 will give you 99. So 8.99, whatever be the first two octets for any class B network, you can just try to prefix it 172.16.8.99. let's verify this here. A and this time to 147. You can hear this address, you can see this address. I will zoom it. 2147 corresponds to 172.16.8.99. This is how, my brothers, you can calculate the addresses for any network. Even in class A you can go up to at least to 65,534 and little beyond, that address range. After that, this calculation and this method is going crazy. So I noticed that this is very good to calculate the addresses for this one. And you might be wondering, why do we need to calculate them? Okay, if you are a network administrator, you might define a DHCP pool to be allotted or to be allocated to the devices in your network. Okay, and it's a random range. This can also be done inside if you have a private organization. Okay, this can also be done and divided according to your convenience. If you are using first group of this from the same network will go to these devices and that, like this, whatever be the case, it might be used in so many scenarios. You may just need to figure out where it is beneficial for you. So this is how we can calculate the addresses for class B networks which are beyond 254. I hope you like this, you are going to like this video. And now I would like to thank you for being patient with me all this time. See you in the next video. Take care. Bye.